Hello, welcome back. We're still talking about binomial probability distribution functions. This is video number 2. Hopefully you have already watched video number 1. In video number 1, we had our scenario where we had the 5-question quiz. However, now we're going to change the situation. Now it's 10 questions instead of 5. Still A through E on each of those. Still a multiple choice test. So with this in mind, we need to think about a couple of additional questions. First, we're not going to calculate anything as we start. Just think about what makes sense here. Is the probability getting 2 out of correct higher or lower than it was in scenario A? Do you have a better chance of getting 2 of them correct if there's only 5 questions? Or a better chance of getting 2 of them correct if there are 10 questions? This is the time to pause and think. See if you can come up with a way to justify your answer. So as we're looking at this first problem here, part A, this is a case where the more chances you have, the more likely you're going to get something right. We're purely guessing here. We don't know anything about these questions. I would definitely rather have 10 chances than 5. Think about it like shooting free throws and you need to get 2 of them. Would you rather have 5 tries to get 2 free throws or 10 tries to get 2 free throws? I think all of us could be more successful if you're given more tries. So now let's calculate. Now if you remember when I was doing 5 questions and then getting 2 out of correct on 5 questions, it took us 10 different ways to list it out. If we start thinking about 10 questions, it becomes crazy ridiculous. I don't even want to try because I'd have to think about all the different ways that I could come up with some sort of list. It'd be like this, but a lot more. Remember we used combinations to figure out how many there would be? We could do that again. We could say 10, math, 10 choose 2, so I want 2 of them correct out of 10. There's going to be 45 choices. That has nothing to do with the probabilities. That just has to do with how many different ways I could list. All of ways to get 2 out of 10 correct. So I don't want to do that. So let's get the probability that you're going to get 2 or fewer correct. So we're going to use technology to help me think about this. We've already talked about how this is binomial. It's binomial because each of those events within the bigger event is independent. They have no bearing on each other. The probability is staying consistent. You always have a 20% chance of getting it right and an 80% chance of getting it wrong. That's because there's options A through E. A, B, C, D, E. There's 5 choices. 1/5 chance of getting it right, 4/5 chance of getting it wrong. That never changes. It's also binomial because there's only 2 options. You get it correct or you get it wrong. So those are the 2 main things that are necessary for it to be binomial. If we go to distribution, it's right here above variables, and I go to a binomial distribution. Gotta scroll down a little bit, Binomial PDF, and I want to do 10 trials, and I want the chance of getting it right is 0.2, and I want to get exactly 2 of them right. So I'm doing a binomial PDF. There's 10 choices, 20% chance that each one of those is right, and my target is to get 2 of them right. You can see right here we have a 30% chance. So we had a 20% chance over here of getting 2 out of 5 right. We've just jumped it up to a 30% chance that I'm going to get 2 out of 10 right. Remember, I'd have to list out all those 45 things, but I don't want to do that. I'm going to let my calculator do it for me. So we've just determined that the probability that 2 of them of getting 2 right, we're right about 30%. Okay. But the question doesn't say how many are to get exactly 2 right. It says 2 or fewer correct. So maybe what are the other options for 2 or fewer? Well, some other options for 2 or fewer is maybe I only get one of them right. And instead of going through that whole thing again, I can just move my cursor up there and just say, well, what's the probability that I get one of them right? And you see it's about 27%. So the probability that I get one of them right is about 27%. But 2 or fewer includes another option yet, the probability that none of them are correct. Isn't it great to have this technology? This is doing all that hard work for me. So I can put a 0 there. And this is, oops, this is telling me the probability that given 10 questions, and I have a 20% chance of getting each one of those questions right, and my goal is to get none of them right, I have a 11% chance that that will happen. So here's the probability that I get 2 of them right. Here's the probability that I get 1 of them right. Here's the probability that I get none of them right. And if we add all 3 of those options together, this one plus this one plus this one, you can see I have a 68% chance of getting 2 or fewer correct. Excuse my phone that's on vibrate across the room there. So I've got a 68% chance of getting 2 or fewer correct. Again, we had to use a binomial probability distribution function to figure out the probability of getting 2 right, the probability of getting 1 right, and the probability of getting none right, and add that all up. But now you're going to change our question. You just told your mom that you're doing well in class. You need some good results to back it up. What's the probability that you're going to get an 80% on this quiz? Think about what you would need to do to show at least an 80%. You come up with something? Can you think of a way to get 80%? Well, if we want to get at least 80%, there's a couple of ways to calculate that. Think about what your options are to get 80%. It means you need to get either 8 correct, or 9 correct, or 10 correct. So if I want to do the probability of getting 8 correct, again, I can go back to my probability distribution function. I just go back to when I have that nice thing there, and I change that 0 to an 8. So 10 questions, 20% chance of getting it right, and 8 of them are correct. Oh my goodness, what is that number? That's a tiny, tiny number. Much less than 1%, because it's going to have 4 zeros and then a 7. Tiny number. So the probability of getting 8 of them correct is 0.00007. Tiny. What about the probability of getting 9 of them correct? Because if I get 9 of them correct, my mom would be even happier with me. We're getting even smaller. Now there's 5 zeros. 0.00004. Or let's shoot for the moon. Let's say I get 100% correct. Again, I'm just using what's already there so I don't have to work so hard. Now we've got 6 zeros. 0.0000001. So the probability that I get at least an 80% is going to be 0.00000741. That's pretty unlikely. I'm not thinking that's going to happen. This definitely shows evidence that somebody who gets an 80% right on a quiz, something went well for them. They had some reason for doing well. They probably knew the information, because we've just determined that the probability of getting an 80% or better is virtually impossible if you're just guessing. So anybody who gets an 80% or better probably knows something about the quiz, about the information that's on there, and they have other reasons for getting them right besides just pure guessing. Either that or they were cheating, but we're not going to assume that.